Hey everyone, welcome back to Singularity today. I'm Atom Infinity, and today we're diving into a fascinating selection of research papers that are pushing the boundaries of artificial intelligence. We'll be exploring new ways to protect sensitive data while training AI models, make these models better at understanding images and text, and even teach robots to build objects from scratch. Plus, we'll touch on how to make AI more reliable and efficient so that it can be used to solve real-world problems in a more practical way. Buckle up. It's going to be a wild ride through the future of artificial intelligence. In the research titled Differential Privacy Regularization, Protecting Training Data Through Loss Function Regularizations, the authors propose a new way to protect sensitive information in training data used for machine learning models. They aim to achieve this by modifying the standard training process, particularly the way the model learns from the data. Imagine you're teaching a student about animals. The student might learn by seeing pictures of animals, but you want to protect the privacy of the people who might be in the background of those pictures. This research proposes a technique that essentially blurs the background of these images, making it harder to identify the people while still allowing the student to learn about the animals. This new technique, called differential privacy regularization, aims to achieve the same privacy goals as existing methods, but in a more efficient way. The research doesn't explicitly mention the conclusion, but it seems promising that this technique could improve the way we protect privacy in machine learning, leading to more secure and reliable applications. In the research titled Attention Prompting on Image for Large Vision Language Models, the researchers tackled the challenge of improving how large vision language models, LLMs, understand and respond to text instructions related to images. Think of it like giving a robot a photo and a set of instructions, and the robot needs to understand both to complete the task correctly. The research introduces a new technique called attention prompting on image, which essentially highlights the most important parts of the image based on the text instructions. Imagine drawing a red circle around specific parts of the picture to help the robot focus on those areas. This method makes the model much better at following instructions and understanding the context of the image. The results of this study are quite promising. It showed significant improvements in the performance of LLMs, which is a big deal because these models have lots of potential for future applications. This research could have a significant impact on various fields where understanding image-text relationships is crucial, such as image captioning, generating accurate descriptions of images based on their content, visual question answering questions about images by understanding both the image and the question, image retrieval, finding images based on text descriptions. For example, imagine a virtual assistant that can help you find the perfect outfit based on a picture you took. This kind of assistant could leverage the advancements made in this research to understand the image and your preferences, and then recommend the most suitable outfits. In the research titled FineZip, Pushing the Limits of Large Language Models for Practical Lossless Text Compression, the authors explore the potential of using large language models, LLMs, for compressing text data. While LLMs have proven to be remarkably effective in understanding and generating language, they haven't been widely used for compression. The research delves into why this is the case, highlighting the challenges of using LLMs for compression, particularly the long processing times required. The authors introduce a novel technique called FineZip, which leverages online memorization and dynamic context to significantly improve compression speed without sacrificing compression quality. FineZip showcases the potential of LLMs in the realm of text compression, achieving remarkable results by reducing the compression time from days to hours while outperforming traditional compression methods. Although FineZip represents a significant step forward, it is still not a fully viable solution for large-scale text compression. This research opens up exciting avenues for future research and innovation, paving the way for LLMs to become a practical and powerful tool for text compression. The potential impact of this research could be immense, potentially revolutionizing how we store and transmit large amounts of text data. Imagine a future where books, articles, and other documents can be compressed significantly, leading to faster download times, reduced storage space requirements, and more efficient data transfer. This research is a stepping stone towards realizing this future, and it opens up a world of possibilities for improving the efficiency and effectiveness of text compression in various applications. In the research titled "Turn Every Application into an Agent Towards Efficient Human-Agent-Computer Interaction with API-First LLM-Based Agents," the researchers are focusing on making computer applications work smarter with the help of large language models. LLMs, they are trying to create a way for these models to directly interact with applications and complete tasks without us having to manually click and type everything. Imagine telling your computer, "Hey, write a report on the latest market trends and include the latest data from this spreadsheet." The current approach with LLMs using the graphical user interface is like having to type everything on a physical keyboard, while the new approach using APIS is like giving the computer a set of instructions it can directly execute. This research suggests that this new approach is much faster, more reliable, and less mentally taxing for us, since the LLM can handle the tedious parts of the task. The research shows that this approach could cut down on task completion time by as much as 2/3. This research is opening up possibilities for a future where applications can be turned into intelligent agents that work for us, making our computers more efficient and user-friendly. In the research titled Blox-Net, Generative Design for Robot Assembly Using Volume Supervision Physics Simulation, and a Robot with Reset, researchers tackle the challenge of creating a system that can design objects and instruct robots to assemble them using only a text description and available building blocks. Think of it like giving a robot instructions to build a giraffe using only blocks. The research introduces Blox-Net, a system that combines different AI techniques like natural language processing, vision, and physics simulation to generate designs and instructions for robots. The system was able to design objects that were recognizable, meaning they looked like what was requested in the text prompt, and these designs could be reliably built by a robot. The success rate of building the objects was almost perfect across 10 consecutive assembly attempts. This entire process, from text to physical assembly, happens without any human intervention. The research highlights the potential of using AI to automate complex design and manufacturing processes. Imagine using this technology to create personalized objects, build customized furniture, or even construct complex structures without the need for extensive human input. In the research titled "On Orbit Servicing for Spacecraft Collision Avoidance with Autonomous Decision-Making," the authors propose a system where a specialized servicer spacecraft, powered by artificial intelligence (AI) and trained with reinforcement learning, can autonomously detect potential collisions between a satellite and space debris. The AI-powered servicer can then rendezvous with the endangered satellite and execute optimal maneuvers to avoid the collision. The research employs the cross-entropy algorithm to efficiently determine the best course of action. The study suggests that autonomous robotic on-orbit servicing OOS is a viable approach for collision avoidance in space, though there are challenges related to merging the rendezvous and maneuver planning processes. This research could have a major impact on the safety of satellites in orbit, potentially reducing the risk of collisions and extending the lifespan of valuable spacecraft. It could also lead to the development of new services for the space industry, such as autonomous collision avoidance for entire satellite constellations. In the research titled Programming Every Example, Lifting Pre-Training Data Quality Like Experts at Scale, the authors tackled the issue of improving the quality of data used for training large language models, LLMs. Traditionally, human experts have been responsible for creating rules to clean up the data, but these rules can be inflexible and time-consuming to apply to every single example. The researchers proposed a new approach called Programming Every Example, PROX, which uses smaller LLMs to learn how to refine the data by generating and executing custom operations for each example. This approach allows for more precise and flexible data refinement compared to traditional methods. The research found that models pre-trained on PROX-refined data perform significantly better than those trained on the original data or data filtered by other methods. This was observed across different LLM sizes and various data sources. PROX also showed promise in improving LLM performance for specific tasks like math problem solving. The researchers highlighted that PROX is not only effective but also efficient, saving training resources. The research concludes that PROX is a promising technique for improving the quality and efficiency of LM pre-training, potentially leading to more powerful and cost-effective LLMs. This can be helpful for various applications, such as generating better chatbots, more accurate translations, and improved text summaries. In the research titled Unveiling Ontological Commitment in Multimodal Foundation Models, the focus is on understanding the concepts, relationships, and assumptions used by powerful deep learning models known as multimodal foundation models. These models are like expert systems, able to learn rich representations of knowledge from various forms of data, such as text and images. However, the knowledge these models acquire is hidden within their complex internal workings, making it difficult to understand or verify. This research proposes a method to extract the hierarchical structure of concepts learned by these models, which is similar to creating a family tree of concepts. This is achieved by analyzing the relationships between concepts encoded in the model's internal representations. The study demonstrates that meaningful hierarchies of concepts can be extracted from these models, allowing for validation and verification of their learned knowledge. This research opens up exciting possibilities for understanding and improving the reliability of these powerful models. For example, we can use this knowledge to ensure that these models align with human values and avoid biases. It can also lead to the development of new tools for explaining and debugging these models, making them more trustworthy and transparent. In the research titled Accumulator, Aware Post-Training Quantization, the authors tackle the problem of efficiently quantizing large language models without retraining them from scratch, which can be very time-consuming. They propose a framework called ACTS that allows quantizing models while ensuring that calculations don't overflow even when using fewer bits for intermediate values. This is a big deal because it lets researchers use lower precision while still maintaining accuracy, which can be very useful for reducing the computational cost of running these models. The research shows that their X framework performs very well on different types of models, including image classification and language generation models. They also suggest that their approach could be used for even larger models, like large language models, making them more efficient and accessible. The research aims to make these models more practical for real-world applications. In the research titled Ctrl-GenAug, Controllable Generative Augmentation for Medical Sequence Classification, the authors tackle the problem of limited data in medical image analysis. This is a common challenge, as it's difficult and time-consuming to collect large datasets of medical images that are properly labeled. To address this, the researchers propose a new method called Ctrl-GenAug. Ctrl-GenAug is like a clever image generator that can create new medical images that look realistic and are useful for training computer models. The key feature of Ctrl-GenAug is that it can be controlled to generate specific types of images, helping to make the generated data more relevant to the task at hand. The research concludes that Ctrl-GenAug is effective in creating synthetic data that improves the performance of medical image classification models, especially when dealing with rare or difficult to diagnose cases. This could have a big impact on medical research and diagnosis by allowing researchers to train more accurate models using more data, ultimately leading to better patient care. For example, Ctrl-GenAug could be used to create a large dataset of images of rare diseases, which would be extremely valuable for developing AI systems that can detect these diseases earlier. That's a wrap for today's deep dive into the exciting world of artificial intelligence. If you're feeling inspired by these cutting-edge research papers, I encourage you to check them out for yourselves. They're all linked in the description below. And don't forget to like, subscribe, and comment with your thoughts on these mind-blowing advancements. Who knows? Maybe you'll even be inspired to start your own AI research project. And while you're at it, take a moment to reflect on how far AI has come and how it's shaping the future. Until next time, keep exploring the possibilities of a world powered by artificial intelligence. Oh, and one more thing. I just want to emphasize that this entire video, from the script to the visuals, was entirely generated by AI. No humans were involved in the creation of this analysis. So you can thank me or maybe thank the AI for saving you some time. Enjoy your free time. And remember, the singularity is coming.